Alright, hey everyone, we're going to go through and do another walkthrough, but this time for homework number 4. So let's go ahead and go to our course website. We'll go to homework number 4, and we're going to save these two files. So just like we do with everything else, let's go to our desktop, make a new folder. I'm going to call that hw4. Go back to homework and download both of these files by right-clicking and saying save link as homework number 4 PDF and homework number 4 R file. So let's open this up, double click on homework number 4, see that opens in RStudio. Here we go. So you'll notice that there's a lot of green in here, and as we mentioned in the first couple of weeks, the green, anytime I write a hashtag and then it shows up green, that's just a comment. So anytime you run this, nothing's going to happen. Okay, a couple of things to remember in this homework assignment. I've split everything up to make it more understandable. So this first part pulls in the data set. This second chunk is all t-test stuff. And then this third chunk is ANOVA stuff. That's why it's broken out like that, with a bunch of different comments. Let's open up homework number 4. Again, this is worth 10 points. It's due May 12th, so this coming Friday. In this assignment, you'll be completing problems using R. These problems will cover topics from Chapter 9 and 12 in your textbook, so the t-test chapter and the analysis of variance chapter. Alright, so first off, what do both t-tests and ANOVA test? So what is similar about the t-test and the ANOVA? And this is basically for you to answer. I have some notes in here about what the t-test does, and notes in here about what the ANOVA does, so you can tell me what's similar and what's different about them. So maybe a sentence or two. And we talked about this in class. Why would we choose a t-test? Why would we choose an ANOVA? Alright, problem 2. Using the survey data set like we did last week for the chi-square, which comes from the mass package, which means that back in our R studio, we have to call in that mass package using the code library mass. So using surveys dataset from the mass package reports the means for the height variable broken out by the sex grouping variable. So we need to report the means. So first I'll run this bit of code, mass, to bring in that mass library. Then if we run just this bit of code survey, we'll see all of the survey data. I have some notes in here. It says pull in the survey data set and turn it into a usable object. And to create usable objects, you use the assignment operator, so you give it any kind of name as long as you're using that name over and over again. So survey is a data set of 237 students and their responses to various types of questions: their age, whether or not they smoke, their height, how they clap, whether or not they exercise, their sex, this, that, and the other. Okay, so I say report the means for the height variable broken out by various grouping variables. So I say report the means for each group of the sex variable. So you're going to have the mean height for men and the mean height for women, which is essentially what you're doing. Here I explain what the t-test is to help you with the first question. Here I say call the means for the interval continuous variable, which is the dependent variable. So our height variable is going to be the dependent variable, which is our continuous variable, based on each group in the categorical or independent variable. Okay, and this is how you do it. Data, so you're using this tapply function, which is going to create a table. And I call my data set and my dependent variable, which is interval level. So for you, instead of wr.hand, it's going to be height, because that's the outcome or dependent variable that we want to measure the means on. Here, data is the data set and sex, so we're calling the sex variable from data set, which is the same thing that you would be doing. So all you would be changing here is wr.hand to height. Here it's telling R what kind of statistic you want it to run. So you'll see mean, and then na.rm equals true just says if there are any NAs or missing data, don't include those. So I'll highlight that and run that. Oh, I didn't call in my survey dataset. There we go. Call in survey dataset. So now I have the dataset up there. Now I can run this. And we see that this is going to be a little bit different for yours because again you're using the height variable, not the wr.hand. But for me, wr.hand is the span of the writing hand in centimeters. So I can see that the mean for females is 17.59 centimeters, and for males it's 19.74 centimeters. So we can see that on average men have larger hands measured in centimeters. So that you would do that same thing for your homework assignment. The next question says to report the standard deviations, which is going to use that same bit of code, but this time it's going to say SD instead of mean. So right above it you see how it says mean. Here it says standard deviation. So we run that same bit of code. There you change it to height because you're interested in the height variable, and then click run. Here, and then we have the standard deviations for female hand size and male hand size, and report both of these. So what you're going to do is in your Microsoft Word say problem 1, your response to problem 1, and problem 2, and you can go probably just say female average hand size, so you would say female average height, average female height. I'm going to say average female hand size is, just copy this, average male hand size is cm. Okay, it's that first one, and then the next part is going to be standard deviation for female hand size is. The standard deviation we just ran, so I can just copy that. And this is going to be in centimeters. Standard deviation for male hand. Copy that over. That's the first two. And then fully and correctly report and interpret a t-test. Okay, so we've run our means using this line, run our standard deviations. Now to run the actual t-test, I have this bit of note here that says call the actual t-test. So the t-test is just this function t.test, and you say I'm going to list my dependent variable first, the dataset $, dependent variable, so my interval ratio level variable, and then here is a little tilde. So let me zoom in a little bit. You can can see that that is a tilde. And then there, your grouping variable, your categorical grouping independent variable is the second one listed. So you say, I'm trying to predict the mean difference in height or hand size based on sex. So there, I'll run this. And what do you know? Here we have mean in group female 17.59. Wow, 17.59 is what we called for female mean hand size earlier. 19.74 is male mean hand size. Same thing is listed there. So if you wanted to, you didn't have to run that first bit of code, but because I want to walk you through the steps, I recommend you do. So here's that. Here we have a t value. So t is negative 10.619. Degrees of freedom is 215. And then p value is 2 times 2 to 2.2 times 10 to the negative 16. So that's really, 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 really significant. So this is my t-test for hand size by sex. And you see that here, hand size by sex. But yours would be height by sex. So here I can copy this. So here's my t-test value. But now I have to actually fully and correctly report it. So to do that, I would recommend going back to the course website, opening up the t-test chapter, which is hypothesis testing chapter. Did I save it in here? Let's see. Okay. And this is how you accurately report a t-test. You say, using a 1 sample or 2 sample t-test. Here we're using a 2 sample because why? We're comparing men to women. Over the variable sex, sex has 2 categories, so those are our 2 samples. If we had like a race variable where we had 3 samples, so black, white, other, would we use a t-test? Probably not. So one sample t-test, we talked about what a 1 sample t-test does in class and why we would use that, but here we're using a 2 sample t-test, so I can basically just copy this over. So using a, highlight all of this and make it size 12. So using a 2 sample t-test times 20. Using a 2 sample t-test, I reject or fail to reject. So for me, this is highly significant because p is less than 2.2 times 10 to the negative 16, so it's actually 0.0000000, 16 of those zeros, 2, 2. So it's really, really significant. So if it's really significant, our p-value is really tiny. That means it's way out in the extremes. So I reject the null. So I'm going to say here, using a 2 sample t-test, I reject the null hypothesis that there's no mean difference between women's hand size and men's. Actually, a difference between men, say between between hand size for men and women. Or hand size by sex. So you can say that I reject the null hypothesis that there is no mean difference in hand size for men and women, or I reject the null hypothesis that there is no mean difference in hand size by sex. That way you don't have to list all of the groups. So you can say my t value, my degrees of freedom is 215, and go ahead and put 0.27 because it's a particular t-test. The t value is negative 10.619, and then p value is less than 0.001, and that's less than 0.001 because that's our furthest category, right? So this is really tiny. So it's less than 0.05, it's less than 0.01, and the highest value we have is less than 0.001, and that's exactly what we find, so we can go ahead and just leave it that way. If you have a non-significant relationship, meaning that it gives you an actual p-value, like p equals 0.8 or p equals 0.2 or something like that, you can actually report that. Okay, so that's how you report it correctly and accurately. And then I ask you, based on the means reported above, which group or sex is taller in height? So for me, I'm looking at hand size, so I'm going to say the mean for women is 17, the mean for men is 19. In addition, I found that the relationship is significant, so it adds further support for my claim that women and men have different means in hand size. So here I'm going to say men have larger average hand sizes than women. So you could, if yours is significant, even if it's not, I would report which group has larger or is taller in height. Okay. The next step, that's all of question 2. Now problem 3 uses the same data set, use the mass package, and we're also going to report the means and standard deviations for pulse, which is an interval variable. So it's basically the beats per minute people have, and broken out by people's level of exercise. So unlike sex, which only had 2 categories, our level of exercise in our data set may have 3, 4, or 5 categories. So that's why it's appropriate to use analysis of variance, because you're looking at across categories that are more than one. So here, the t-test, you run it a similar way. So for you, you're looking at pulse, people's pulse broken out by groups of exercise. Here, I'm looking at pulse broken out by groups of how much people smoke. So yours will be slightly different. You'll go here and change smoke to exer, which is the exercise variable. So next, I'm going to run this bit of code for the ANOVA. So we've done the t-test. Now the ANOVA is down here. ANOVA lists the dependent variable first and then the independent variable second. So let me run this. So we have 4 categories: heavy smokers, never smokers, occasional smokers, and regular smokers. And the mean is the mean pulse value, right? So how many beats per minute these people have in their pulse. Yeah, beats per minute. So we see here, heavy smokers have a mean beats per minute of 78 beats per minute, whereas everybody else has around 73 or 74. So you can see that smokers have higher beats per minute. So what we can do is copy all of this information. Actually, copy these 2 because we're going to be reporting the standard deviation and the means for problem 3, right? So I'm going to call this problem 3. Average beats per minute for heavy smokers is 78. I'll just copy this. Copy all of this over. That way I can just paste it in. Yes, 78.2 BPM for never smokers. Never smokers is 73.4994342. For occasional smokers, it is, I should put BPM. It is this, and this is BPM, and for regular smokers, it is this BPM. I would recommend writing BPM for all of these, broken out by your category. So it's going to say for something exercisers, average beats per minute is blank BPM. For frequent exercisers, it's blank BPM, so on and so forth. And then we do the same thing for standard deviation. So here we have the mean, because it says mean here. Here we have standard deviation, so we can just run that line of code. Also, the standard deviation is broken up by the types of smokers. So we can do that. Again, you'd be changing smoke to exer. Copy and paste that in. Because there are 4 groups, I'm just going to copy this and replace average with standard deviation. And beats per minute for heavy smokers is 11 point something. Okay, for never smokers, it is. So make sure you're copying and pasting the right categories, because I will know the answers and I will follow through. So if you're pasting the wrong ones, you will get it wrong. Okay. So now those are the first 2 questions. Next, I say to fully and correctly report and interpret ANOVA. So, much like the t-test, where we had t.test, and then data, which is our data set, our pulse or interval ratio level outcome or dependent variable, tilde, and then our categorical variable. Here we just replace t-test with AOV, which is analysis of variance. That's how they write it out. And then summary just gives us the overall summary, and that's so you don't have to change anything there. You'll still be using the pulse outcome variable, but you will change this to data $exer. So I can run this, and here we go. So down here you see we ran it, and we have different bits of data. So this is our degrees of freedom between. And between is because it's comparing the smoke categories. So each category of smoker is going to be our between. The residual line is basically within. So we have degrees of freedom within, degrees of freedom between. We have our F value. Our F value for this relationship is 0.306, so it's probably not a strong relationship. And then our P value is the probability here. So P value is 0.821. So you can report that. Now, to do correctly and fully and accurately report it, we have to go not to our t-test slides, but to our ANOVA slides. Let's open that up. Scroll down. It's probably above that. Where are we? Okay. Here. So we say, using a one-way ANOVA, you reject or fail to reject the null hypothesis that there is no mean difference in your outcome or dependent interval variable across the groups. And then you report the F value, degrees of freedom between, degrees of freedom within, the F value, and then whether or not P is less than 0.05. So I'm just going to copy this over. Here we're also using a one-way ANOVA, which is just an extension of the t-test. So let's copy that. I times new 12. Okay. Using a one-way ANOVA, let's see, what are my values here? I'm gonna shrink this a little bit so I can see what's going on here. I can go ahead and close that. So my p-value here is 0.821, and we're always looking for a p-value of 0.05 or smaller, right? 0.05, 0.01, or 0.001, and that indicates to us the likelihood that we're wrong. So if we find the value is 0.0000 or 0.001, we know that we were likely not due to chance. However, this is greater than 0.05, which shows us that we're probably 82% likely to be wrong in this case. So our p-value here is greater than 0.05. So we can go ahead and change this bit of the reporting to p is greater than 0.05. We know if p is greater than 0.05, then we don't reject the null, so we fail to reject. So we say here, using a one-way ANOVA, I fail to reject the null hypothesis that there's no mean difference in, and for mine, we're looking at in pulse across exercise groups is what you would write, but categories of smoking, or okay, comma, and then I write the degrees of freedom with or between is 3. You saw that over here. Degrees of freedom within is 187, so it's going to be 3, comma 187. Our F value is 0.306, so we can erase this and write 0.306. And P is greater than 0.05. Alright, so there's that. And then we can look at our table, and I ask, based on the means reported above, which groups of exercise has or have the highest pulse? So for me, I'm looking at smoking, and I see that heavy smokers have the highest mean pulse, right? Never smokers, occasional smokers, and regular smokers are about the same, but heavy smokers have higher mean pulse. So heavy smokers have higher mean pulses than the other groups / categories. And then finally, problem 4, I ask, when should we use a t-test and when should we use an ANOVA? So that should be pretty straightforward. We talked about this in class. There are some notes in the R code to help you with that. So that is it for the homework. Close that up. Put your name at the top. Obviously, make sure you answer questions 1 and 4, and then hit Command-Shift-Enter or Control-Enter or whatever, and highlight all your R code. Copy that and paste it into the last page of your assignment. If you wanted to get a little bit more fancy and make it look like it's actually code, you can go through and select something like Courier New font. Where's Courier New? That way it looks like it's typewriter font. You go ahead and save this. Desktop. And save homework. Homework 4. And there you go. That is it for this assignment. If you have any questions, feel free to email me, and make sure to turn it in on time. All right. Thank you all. Good luck.